Welcome to Machine Arena, where we explore the beauty, precision, and power of glass blowing. Today, we take you deep inside the world of glass making, a centuries-old industry that combines fire, skill, and innovation in fascinating ways. Our journey into the world of glass begins in a place of intense heat and skilled hands. Here, you see the workers actively engaged in the meticulous process of creating rolled table cathedral glass. Their primary focus at this stage is managing the molten glass as it emerges from the colossal furnace. Watch closely as a team of workers meticulously guides the glowing, viscous stream of molten glass from its fiery source. They aren't just letting it flow, they're directing and pouring this incandescent liquid with incredible precision onto a large, flat, heat-resistant table. This isn't a casual action. It requires strength, coordination, and a deep understanding of the material's behavior at extreme temperatures. Immediately after pouring, large, heavy rollers are brought into play. The workers operate these machines, carefully lowering and pressing them onto the molten glass. This action simultaneously shapes the glass into a uniform sheet and imprints those distinctive patterns that give cathedral glass its unique texture. The timing here is critical. The glass must be hot enough to be shaped, but cool enough to retain its form. As the glass cools and hardens slightly, other workers begin the cutting process. You'll observe them using specialized tools, often with long handles to protect from the residual heat, to score and snap the edges, trimming the sheet to its desired dimensions. This isn't just about making straight lines. It's about making clean, precise cuts in a material that is still undergoing a transformation from liquid to solid. Every step, from the controlled pouring to the precise cutting, demonstrates the incredible skill and coordinated effort of these artisans. They are not merely observing, they are actively shaping, controlling, and transforming the raw, molten material into a beautiful and functional product. Now, we move deeper into the hand-blown flat glass process, a method where tradition and science meet in spectacular form. The procedure begins with gathering molten glass from the furnace and shaping it into a balloon-like form using breath, motion, and heat. The pipe must be constantly rotated to ensure even wall thickness. Workers alternate between inflating the glass and reheating it, keeping it soft yet stable, a process demanding control, strength, and patience. As the bubble expands, the artisan begins forming a long cylinder. At the right moment, the ends are carefully opened, and the entire piece is scored and cut. This cylinder is then transferred to a reheating chamber where it is gently flattened into a wide sheet. The final result? A flat pane with subtle waves, the signature of handmade craftsmanship. These sheets are highly valued not just for their beauty, but for their uniqueness. No two are ever the same. You'll notice the rhythmic dance, blowing, reheating in the furnace, shaping, and then repeating the process. It's not just about strength. It's about a profound understanding of the material, how it responds to heat, gravity, and air pressure. The glass is gradually expanded into a large, balloon-like bubble. This isn't just for show. It's a crucial step in creating large, flat sheets without the use of machinery. Once the bubble reaches the desired size, the ends are carefully opened, and the cylinder is then skillfully cut and flattened in a separate reheating process. The resulting sheets often possess a subtle, wavy quality, a testament to their handmade origin, which many find adds to their charm and character. This artisanal approach allows for unique textures and variations that automated processes simply cannot replicate. What makes this process so compelling is how it emphasizes the relationship between human and material. There's no room for error. The glassblower must understand the exact point where heat and gravity work in harmony, This is not just art, it's industry, honed through repetition, perfected over time. Through this technique, we see how the past continues to inform present-day manufacturing, preserving skill while producing functional beauty. In this segment, we witness the creation of a custom glass award, a process where craftsmanship, timing, and heat control all come together in perfect harmony. The journey begins at the furnace, where the artist gathers a heavy glob of molten glass on the end of a metal blowpipe. The glass is over 2,000 degrees Fahrenheit, glowing orange and moving like thick syrup. A second gather is added, layering different types or colors of glass to create dimension and depth within the final piece. The shaping process starts immediately. There is no pause. The material responds instantly to gravity, and the clock is always ticking. The artisan uses simple but time-tested tools, wooden paddles soaked in water, metal tweezers, shears, and even folded newspaper. With careful motion, they push and pull, guiding the form into elegant curves. As the glass begins to cool, it stiffens rapidly. It must be reheated in the glory hole, a secondary furnace that keeps the material workable without fully remelting it. This reheating allows for additional shaping, twisting, or stretching, depending on the desired look. If the piece includes fine details or decorative flourishes, assistants may step in to help, turning the pipe, applying heat with torches, or attaching extra elements. It's a team effort, and coordination is essential. Once the final shape is achieved, the piece is carefully detached from the pipe and transferred to an annealing oven. Here it cools slowly over many hours to relieve internal stress and prevent cracking. Though artistic in nature, this process takes place in a fully industrial setting. The workshop is hot, loud, and highly organized. And while each trophy is unique, the discipline behind its creation is rooted in the principles of large-scale production, heat management, timing, material science, and teamwork. Inside this vibrant African glass factory, the workday begins early and intensely. The furnace, already blazing, holds a thick pool of molten glass glowing bright orange, its surface constantly stirred by heat. Workers, dressed in thick protective clothing and gloves, step into place. It's time to begin the first orb of the day. One glass blower dips a long blowpipe deep into the furnace, rotating steadily to gather a sizable portion of molten glass onto the pipe's tip. This first gather is heavy and hot. The worker lifts the pipe carefully, then steps back from the heat, turning the glowing mass continuously to keep it from sagging. He brings the pipe to a shaping bench, where another worker stands ready. With a quick, practiced breath, the blower begins to inflate the glass. The assistant rolls the pipe gently over a smooth metal rail, called a marver, shaping the mass while keeping it centered. As the orb begins to form, it must be constantly reheated in a smaller chamber known as the glory hole. This ensures the outer layer stays soft and workable. With each reheating, the form grows larger and more defined. Another worker joins in to help support the pipe's weight, now too heavy for one person to handle alone. Together, they rotate and angle the glass, carefully managing airflow, watching for signs of uneven inflation. The process is not rushed. It's a quiet, focused rhythm. Reheat, rotate, inflate, inspect. Using large wooden paddles and soaked newspaper, the team shapes the surface, smoothing out bumps, gently adjusting the curve. There are no molds. Every orb is formed freehand, relying on the team's experience and visual judgment. When the orb reaches its intended size, often over 2 feet wide, the final touches begin. The neck is narrowed with metal jacks, and the piece is gently detached from the pipe. At this moment, precision is critical. One wrong move, one small crack, and the entire piece could shatter. The detached orb is immediately transferred to a special holding rod and returned to the reheating chamber for a final round of surface refinement. Small imperfections are corrected using hand torches or careful paddling. Then comes the transfer to the annealing oven, a long, temperature-controlled chamber where the orb will cool slowly over many hours. This cooling process is essential to prevent stress fractures and ensure durability. These large decorative orbs are more than just beautiful. They're functional, durable, and made to last. Once cooled and cleaned, they are often used in restaurants, hotels, or modern homes as pendant lighting or sculptural installations. We move from the handcrafted world of glassmaking into the heart of industrial mass production, the manufacturing of glass bottles. This highly automated process is designed for efficiency, precision, and speed, producing thousands of identical units every hour to meet global demand. It all starts with raw materials, primarily silica sand, combined with soda ash, limestone, and often recycled glass, known as cullet. These ingredients are carefully measured and mixed, then fed into a furnace heated to over 1,500 degrees Celsius. At these extreme temperatures, the raw materials melt into a thick, glowing liquid, the starting point of all glass containers. From here, the molten glass flows into a device called the feeder, which controls the flow and portions the glass into uniform segments called gobs. Each gob is a precisely sized blob of hot glass, just the right amount to form a single bottle. These gobs are dropped into molds where the shaping process begins. Two main techniques are used, blow and blow and press and blow. In the blow and blow method, a puff of air forms a cavity inside the gob, followed by a second blast that expands it to fill the final mold. In the press and blow method, a plunger first pushes the glass into shape before air is used to refine it. The choice of method depends on the desired thickness and shape of the bottle. Within seconds, A fully formed bottle emerges, still glowing from the heat, but already recognizable in its final form. At this stage, the glass is extremely fragile and under internal stress. That's why every bottle passes through an annealing layer, a long, temperature-controlled tunnel where the glass cools gradually over several hours. This slow cooling relieves internal tension and strengthens the structure. As the bottles exit the annealing stage, they undergo a rigorous quality control process. Automated cameras scan each unit for defects, such as bubbles, cracks, or uneven thickness. Anything that doesn't meet strict specifications is removed and recycled immediately. From there, the bottles are cleaned, labeled, and prepared for filling and packaging. Depending on the intended use, whether for water, soda, cosmetics, or pharmaceuticals, the final steps may include sterilization, logo embossing, or coating for added durability. This process is a remarkable example of modern engineering, combining raw natural materials, high heat, precision mechanics, and continuous monitoring. And yet it still follows the same foundational steps used for centuries: melt, shape, cool, and inspect. Mass production doesn't eliminate craftsmanship, it just reshapes it. In this case, it allows us to meet the world's growing need for safe, recyclable packaging while preserving the timeless qualities that make glass such a valuable material. As we continue our journey through the world of industrial glassmaking, we now explore one of the most transformative innovations in the industry, the float glass process. This method is the foundation of most architectural glass used today, from windows and doors to skyscraper facades and automotive windshields. The process begins with raw materials: fine silica sand, soda ash, dolomite, limestone, and cullet, which is recycled glass from previous batches. These ingredients are mixed in precise proportions and fed continuously into a furnace operating at temperatures above 1,600 degrees Celsius. Inside, the materials melt into a molten glass mixture, glowing with intense heat and ready for forming. But unlike glass blowing or mold casting, float glass is formed in a completely different way. The molten glass exits the furnace and flows onto a wide, flat bath of molten tin. Since glass is lighter than tin and doesn't mix with it, it floats perfectly on top. Gravity and surface tension naturally spread the molten glass across the tin, creating a sheet that is both uniform in thickness and smooth on both sides. Glass ribbon is carefully controlled in both speed and width as it travels across the tin bath. It is then gradually cooled in a special annealing zone, a long, temperature-controlled tunnel that reduces internal stresses and hardens the glass without causing distortion. This stage is essential to ensure the final product is stable, flat, and safe to handle. As the ribbon exits the annealing layer, high-speed machinery cuts the glass into precise sheets. Advanced sensors and computer systems constantly monitor for flaws, such as bubbles, ripples, or contaminants. Only flawless sections are passed along to further processing. Float glass is remarkably versatile. It can be cut, laminated, tempered, or coated to suit different architectural and safety needs. Whether used in a suburban window or a 100-story office tower, it all begins here in the float line. This segment highlights the shift from handcrafted to continuous, high-volume production. Float glass represents the perfect balance of chemistry, engineering, and industrial efficiency, producing one of the most widely used building materials of the modern age. In this test facility, a thick sheet of security glass is put through intense pressure trials. A mechanical arm strikes it repeatedly with a weighted ram, simulating real-world impact. The glass flexes but holds. Next, it's subjected to sharp tools and vibration to test shatter resistance. Even after multiple hits, the layers remain intact. This laminated structure is engineered not to break apart, protecting what lies behind it. Every panel must pass these tests before being approved for use in banks, vehicles, and secure buildings. We close with a glimpse into the future. Glass recycling. Old bottles and windows are crushed into cullet, cleaned, and remelted into fresh glass. This not only saves energy, but also reduces the need for raw materials. Glass is endlessly recyclable, making it one of the most sustainable materials in industry. Every cycle keeps it useful and out of the landfill. In the heart of heavy industry, where fire meets steel, glass is still shaped by human breath. Mouthblown glasswork endures a powerful blend of tradition, labor, and precision, proving that even in mass production, craftsmanship still matters.